So in coordination chemistry, we started with salts. Salts are compounds which have one acid radical and one basic radical. When dissolved in water, they give test of their individual ions. The common examples of salts are NaCl, Na2SO4. They are all salts which have one acid radical and one basic radical. When dissolved in water, they give the test of their individual ions. When you take double salt, you say they are mixture of two or more simple salts with water of crystallization. The most common example being carbonylite. Carbonylite formula is KCl MgCl2 dot 6H2O, or potash alum. Potash alum is FeSO4 NH4 5SO4 dot 6H2O. This is what is more salt. This is carbonylite. And potash alum is what? K2SO4 Al2SO4 thrice. And how many H2O? 24 H2O. These three salts, when they are dissolved in water, they also give test of their individual ions. Like if I take potash alum, I can test potassium, I can test sulfate, I can test aluminium. So I can get the test of basic radical as well as acidic radical. Now we will talk about what salts? Complex salt. Please write. Complex salts are salts which do not give test of individual ions when dissolved. Complex salts are salts which do not give test of the individual ions when dissolved. Example: K4FeCN6, K4FeCN6. This is called as what? Potassium ferrocyanide. This is called as what? This compound is called as what? Potassium ferrocyanide. But this name is one kachada name. It is like Mane Hesuru. We will change it because our original name will become what? Potassium hexacyanoferrate 3. That is how we have to learn. So commonly it is called as what? Potassium ferrocyanide. If I eat this or drink this, I will never die because I don't have any cyanide ion in my solution, as anything which is written within this square bracket does not ionize. It is called as what entity? Coordination entity. It is called as what entity? Coordination entity. And anything which you write within this square bracket is called as the coordination sphere, and it does not ionize. So this is what kind of complex, this is what kind of a salt? It is a complex salt because it should give test of potassium ion, Fe+2 and Cn-, but it gives a test of what? 4K plus a new ion which is called as ferrocyanide ion. Understood? So the study of these complex ions or these complex salts is called as what chemistry? Coordination chemistry. So anything which you write within the square bracket, anything which you write within the square bracket is called as what? Coordination sphere. And whatever you write within it is called as what entity? Coordination entity. Nothing will come out of that sphere. When you ionize it, they ionize as one cation and one anion. You will not get two cations here because one goes in the form of what salt? Complex salt or a complex ion. Okay, so here we saw which was a complex ion. The anion was complex. Now we will see one cationic complex. Let us understand. Cu NH3 whole 4 CuNH3 pole 4 SO4. What is the name of this compound? Cupraammonium sulfate. This is again common name. It is called what? Cupraammonium sulfate. Fine. If I take this salt and I test the presence of ammonia or ammonium ion in it, or I put what agent? Nessler's reagent. Confirmatory test of ammonia is using Nessler's reagent now. You take a solution, salt solution, add Nessler's reagent to it, you get what? A dirty brown or black precipitate. Ammonia is confirmed. Or the best test of ammonia is done, which you should not do it in lab, but it is the most easiest test when your teacher should not see you. Take some salt, put a drop of NaOH in it, okay, and then rub it. And then throw it and smell it. If it smells like Sulabh Shauchalaya, it is ammonia. You understood? If it smells like school toilet or college toilet, exception NPS, okay? If it smells like any school or college toilet, that means it is what? Ammonia. But don't do it in presence of your teacher, because that is not considered to be done. But that is the best confirmatory test of salt, particularly which has any kind of ammonia. Or another one which you do is, you take a concentrated HCl rod and place it in the mouth of the test tube. If you get that Z horror show, ka white smoke coming out, dense ammonium chloride smoke, it is ammonia. Confirmatory test is only done to confirm it for the teacher, because you would have already know what the salt is. So basically try to learn how to identify, because if ammonia is there, ammonia is a non-interfering radical. So you can do it at the beginning and then you can directly go in for acid radical. And most of the time, for your easiness, we tend to give lot of ammonium salts as they are easier to identify. Ammonium nitrate, ammonium sulfate, ammonium chloride, ammonium bromide. For CBSE student, oxalate is there. Huh? Fine. So generally, you will have all these compounds. But in this case, if I try to check the presence of ammonia, if I add Nessler's reagent, I will never get a precipitate of ammonia. This is because there is no ammonia present. Instead of it, you get a new ion, which is called as what? Cupraammonium ion plus SO4 2 minus. So this is a complex anion. This is a complex cation. The study of these complex ions or salts are called as what chemistry? Coordination chemistry. So what is that square bracket called as? Coordination sphere. And whatever you write within it is called as what? Coordination entity. Clear? Both examples to be written, please. Cupraammonium sulfate as well as potassium ferrocyanide. Please write below. Complex salt. The study of these complex salts is called coordination chemistry. The study of these complex salts is called as coordination chemistry. Fine. Now open your textbook. There is no point making you write, but these definitions are very important. So please come to page number, I don't know. In my book 240, in your book I don't know. In your book where it is, we are not here. We are in the beginning. No, we didn't do this. We are not. No, that chlorophyll and all we did. But okay, this is definition. This is page number what? 247. Okay, I have not done Warner theory, but I will do it in the end. Okay, so page number 247. I'll explain everything with an example so that you understand, but all definitions are important. Sometimes a 5-mark question comes from coordination chemistry as define coordination entity, define ligand, define coordination number, define coordination sphere, and define coordination polyhedron. So all definitions are very important. Fine. So first thing, coordination entity. Now, let us understand what is a coordination entity. So, first thing, I will take again ferrocyanide ion. I will try to explain most of the things using this ion. It's very nice, प्यारा वाला ion है, ठीक है? So what is in this coordination entity? A coordination entity consists of what? A central metal atom, which is what? Iron. Right? Along with it, it consists another group of atoms which are called as ligands. Okay? If it is pronounced badly, it really gives some other meanings. And we are all from a Hindi medium school, so we know how bad it was taught. So this is called as what? Ligands. Some call it as ligands, whichever way you want. These are atoms which give lone pair electron to the metal atom. Okay? So a coordination entity always consists of a central metal atom and donor atoms, which are called ligands, which donate their lone pair electron to the central metal atom, forming what bond? Coordinate bonds. So this is called as what entity? Coordination entity. Clear? In a complex sort, within the coordination sphere, you will always have what? A central metal atom and few donor atoms. If all the donor atoms are same, they are called homoleptic complexes. If they are different, they are called heteroleptic complexes. So first thing, in a coordination entity, we will always have a central metal atom and donor atoms. These donor atoms are called ligands. These donate a lone pair of electron to the metal atom, forming what bond? Coordinate bond. This is called as what entity? Coordination entity. If I take now CuNH3 whole 4 plus 2 consists of a central metal atom copper and ligand ammonia, which gives lone pair of electron to copper, thus forming what bonds? Coordinate bond. This is called as what entity? Coordination entity. Is it clear? Become clear? Chalo, coordination entity we will read. Underline important definition. A coordination entity consists or constitutes of a central metal atom or an ion bonded to a fixed number of ions or molecules. See here, fixed number was 6. Here it was 4. If the number is 6, they are called what complexes? Octahedral complex. Hexahedral 6 andre octahedral complexes. If it is 4, they are called tetrahedral complexes. They always are surrounded, the central metal atom is surrounded by fixed number of atoms or ions. For example, in COCl3NH3 whole thrice is a coordination entity in which the cobalt ion is surrounded by 3 ammonia molecules and 3 chloride ions. So anything what you write within the square bracket becomes what? Coordination entity. It consists of a central metal atom and fixed number of donor atoms, which are called ligands, which donate lone pair of electron to the central metal atom, forming what bond? Coordinate bond. So is coordination entity clear? It is always written within square brackets. It consists of a central metal atom. Surrounding it are fixed number of atoms or ions. Fine. Example not complete. NiCO4, PtCl2NH3 twice, FeCN6 4 minus, CONH3 whole 6 plus 3. Correct? Now the second one. Central atom or ion. Central atom or ion basically comes from 3D series. Central metal atom or ions, they generally come from 3D series. 3D series under D block elements, which is present in which period? Third period. We call them as what series? 3D series. Sorry, fourth period. Which are present in fourth period. We call them as what series? 3D series. So you have to remember with their names: scandium 21, titanium vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. Okay, so atomic number 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. ಇದು ಮಧ್ಯರಾತ್ರಿಯಲ್ಲಿ ಎಬ್ಬಿಸಿದ್ರೆ ಗೊತ್ತಿರಬೇಕು. It is what? Scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. This is very important if you learn it now, because even in D block we have to make you learn this. So please write beside central metal atom and ion this series. Scandium with their atomic numbers. Scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. They have their atomic numbers 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. You have studied atomic configuration of chromium and copper as very important, because you know they do not make it as 3D10. They make it as 3D10 4s1. They do not make it as 3D9 and 4s2. This is because of
stability of phosphate
and exchange energy anta eno odidri adannu ondsali refer madಕೊಳ್ಳಿ. I am not telling you what is exchange energy, but just go and check, because it is important for your CET. Clear? So central metal atom or an ion is a metal atom which generally belong to what series in your syllabus? Belongs to 3D series and shows variable valencies. They should always have what orbital? An incompletely filled d orbital. Why? Because if there is an incompletely filled d orbital, the lone pair electron given by the donor atom or ligands can be accommodated there. So what is a central metal atom or an ion? It is a metal atom which should contain an incompletely filled d orbital, so that the electrons donated by the ligands can go and stay there. Fine? Now I am reading that part. The atom to which a fixed number of ions or groups are bound in a geometrical arrangement around it, it's called a central metal atom or ion. For example, nickel, cobalt, iron. These central metal atoms or ions are referred as Lewis acid. Why? Because they accept electrons. Because they accept electrons from the donor atom. Because they accept electron from the donor atom. Now ligands, I am leaving it because it's a big thing for tomorrow. We have to study all types. Of ligands. Okay. Now we will come to coordination number. See, what is coordination number? The total number of donor atoms or the fixed number of donor atoms across the central metal atom in a coordination entity is called as what? Coordination number. Solid state coordination number. The total number of atoms surrounding the main is called as coordination number. Same logic. Across Fe, how many Cn are present? 6 Cn. 1, 2, 3, 4, 5, 6. So the donor atom surrounding, the fixed number of donor atoms surrounding the central metal atom or ion is called as its coordination number. If the coordination number is 6, what complex? Octahedral complex. If the coordination number is 4, it can be two types, either tetrahedral or square planar. I'll teach how and why. It can be tetrahedral or square planar. So what is coordination number? Coordination number is the total number of ligands surrounding the central metal atom or an ion in a coordination entity. Fine? Let us read. The coordination number of a metal ion or a complex can be defined as the number of ligands or donor atoms to which the metal atom is directly bonded. PTCl6, how much? 6. NiNH3 whole 4 plus 2, 4. Thus the coordination number of Pt and Ni are 6 and 4. Similarly in the complex ion, F is, iduna artha agalla because I have not taught you ligands. After doing ligands you will understand how it is 2 and 3 and all that. So that part you leave. It is important to note here that the coordination number is determined only by the number of sigma bonds formed. Underline. Coordination number is determined only by the number of sigma bonds formed by the ligand. Pi bonds if formed between the ligand and the central atom are not counted. So coordination number ke pi bond is not required. Only what bond is required? Sigma bond. Now coordination sphere. You know I have already taught you what is coordination sphere. The square bracket which holds what? The central metal atom and the donor atoms or the ligands in coordinate bond is called as what sphere? Coordination sphere. Anything which is written within the coordination sphere does not ionize. Let us read through it. The central atom or ion and ligands attached to it are enclosed in a square bracket and is collectively known as coordination sphere. The ionizable groups are written outside the coordination sphere. Clear? So we did what? Coordination entity, central metal atom or ion, coordination number and coordination sphere. Clear? I need these definitions to be learnt by tomorrow. You should know it by heart. Okay, Preetam? And everybody, 4 definition kalilebeko and 1 reading of that table of salts. Okay? So tomorrow we meet. Thank you.